we are very excited this week of all weeks to have joining us tonight Matt Kaplan from the Planetary Society. Sail away, everybody. I couldn't even hear who said sail away first. If you think you were in the first person, come on down, get a prize. With that, can I ask Matt to come join us? And there's your clicker.
Great.
So, Matt, tell us all about this.
Well, we're thrilled. We're very proud. We had a very happy staff meeting today. But can I say, first of all, how happy I am to be here?
Oh.
Because as I have told you, I grew up here at Griffith Observatory. Not here because, as I said earlier, this was all dirt. But up there, before I could walk, my parents were bringing me here. So, I mean, I have to... Wait a minute. If I can reach it, I have to complete the outfit. I feel a little odd because normally I'd be wearing a space tie, but I had to wear the LightSail shirt.
Yes, you did.
Yeah. And I have a cheat sheet. Should I just start going into
Sure,
this? Yeah.
please.
So to get started, that is LightSail. And this is the first full resolution image that we got during deployment. The sail is actually not fully deployed at that point, and it's a fisheye lens, so this is kind of corrected. There's been some Photoshop fun here to clean it up a little bit, but isn't that spectacular? And anybody can name that landform that we're sailing about? Baja, that's right. So LightSail has a history that goes back about 10 years, but really we go back about 20 years. Because we attempted to fly the very first solar sail ever 20 years ago, well, almost 20 years ago, when we flew Cosmos 1. And it was a huge spacecraft compared to this one. We had high hopes, but unfortunately, because we could only afford a former Russian or Soviet submarine-launched ICBM, because they gave us a deal. The deal was that we went straight into the Caspian Sea. So we never got to find out. And that's when we went back to the drawing board and came up with what you see here. We've got a little, it's really just sort of a thumbnail style approach, but if this works, you'll actually see the sail being deployed, which is pretty cool. So as this happened, I had been at the launch with a lot of our folks at the Kennedy Space Center, which you'll see some pictures of soon. But for this, I was at our mission control, which was right up the coast. Excuse me, at Cal Poly San Luis Obispo. Here's a picture of our mission control room. Yeah, right. Apollo 11. Here's our control room. And there really are only 6 people sitting at laptops like this one who were controlling a spacecraft in space. Some of the other folks there were other team members who worked on this, and if you look carefully, you can see the youngest member, 3 years old, who was is the daughter of one of the primary team members. So we had a good time up at Cal Poly. Here's the boss. He couldn't be with us. You may know Bill Nye. Might have heard of him, the science guy. He's our CEO, Chief Executive Officer. And he couldn't be with us except virtually, so here he is by Skype.
With a broken wrist, it appears.
I don't know what he did. I didn't get to ask him, even though you can see my watch on the left there because I'm standing just off screen. Here I am about a month, actually 2 months before launch, in the clean room at Cal Poly. I'm a radio person, so I rarely take off my headphones. And there is LightSail on the table going into the P-pod, which is the little thing that has a spring that actually ejects a CubeSat. I don't know how many of you are familiar with the concept of solar sailing, but it's a much older concept than a lot of people realize. And this, I hope this isn't too hard to read up there. It starts up at the top, 1608, with Kepler. And there is one step missing here at the beginning of the, well, at the turn of the 20th century, because that amazing guy, Konstantin Tsiolkovsky, was actually the first person to figure out how this might actually work. And he pretty much worked it all out and did a terrific job. We do it pretty much exactly the way he expected it to be done.
So how does it work? How do you get anywhere?
Well, we're coming to that.
Okay.
But it's surprises a lot of people that light can do the job. It's not the solar wind, as a lot of people suspect. It's the actual photons from the sun. And more about that in a moment. There is the spacecraft. How many of you familiar with CubeSats? Great little format. There are literally thousands of these, either in space or in development, or at least planned by groups as, you know, low level as high schools. A lot of these go through Cal Poly, because Cal Poly and Stanford invented this format for a spacecraft that's based on 10 centimeter by 10 centimeter by 10 centimeter cubes. We have a 3-unit one, so it's about the size of a loaf of bread, roughly 10 by 10 by 30 centimeters. And you're seeing it here with the solar panels deployed, which are probably pretty obvious there, but up there is one of the cameras. And we had, there it is, we have two 2 megabyte, so not too impressive, but cameras that were able to deliver pretty good photos. And we're still downloading those images. We get thumbnails, and then we have to decide which ones we really want to, you know, take up a lot of time as we pass over a ground station and work with. Here is the sail, stowed away. And that becomes this. So our little 10 centimeter wide spacecraft becomes a 5.6 meter wide solar sail. Think of, you know, roughly the size of a boxing ring, as it says there. It's just made out of silverized mylar. It's pretty cheap stuff. It's ripstop, you know, like if you've got a good tent that's made out of ripstop nylon. It's the same stuff in case it gets, you know, perforated by a micrometeoroid. It hopefully won't tear too far, or space junk, which is maybe more likely. So far, so good. Here is a shot of our control panel, or mission control, that anybody can access at our site. You can just go to planetary.org or sail.planetary.org if you want to skip our homepage, and you can monitor where it is. You can also on here catch passes of LightSail as it may be going over your head. Because now that the sail has been deployed, it's big enough, if you catch it near dusk or dawn, you might be able to see it go over you in the sky. You know, so we're up there with the ISS, although on a much smaller budget. Like I said, I was at the launch. And here is an amazing photo of people at Kennedy Space Center. It's lovely to see these faces, but what's really amazing about this is that what you're seeing is entirely the light of the rocket, except for a little bit of help from a big moon and a few stars. It was pitch black there because they turned off all the lights at KSC, so we did have some moonlight, but this is the light of the Falcon Heavy being launched. And of course, we were not the main payload on this.
The Falcon Heavy for your CubeSat, yeah.
Kind of overkill. But there were about more than 25 payloads, and the main one was an Air Force one that we're not allowed to talk about. And it was absolutely spectacular. It didn't happen until about 2:30 in the morning. And yet, by that time, we were all wide awake again because it was just thrilling. And this is actually now being called a rocket nebula or launch nebula. Doesn't it look like an astronomical thing? What you're looking at there, the upper portion of the image up here, that is the backlit portion of the two boosters, the side boosters on the Falcon Heavy, after they've separated, but they're still surrounded by a lot of the exhaust gases. And then above that, below that, you're actually seeing the center core stage with that beautiful image. And if you count, you can count that there were nine engines still going there, because it's basically now a Falcon 9. You know, you have strapped 3 Falcon 9s together for stages, and you got 27 big rocket engines going up into space. This later image from the mission, as I said, we're hoping to get a lot more of these. This may help you push yourself in the image. And as I said, you can catch us right here at sail.planetary.org. To answer your question, because I'm done with slides now, it's true photons don't have mass, as you guys know, but they have momentum. And that momentum, when they strike something, shiny especially, they can impart that momentum in actually two ways. They impart that momentum to that shiny thing or anything, and that's what's allowing us to raise the orbit. We only this week declared success officially on Wednesday of LightSail, because our goal was to raise the apogee, the high point of that ellipse that it is currently in, going round and round the Earth about every 100 minutes. It's up about 700 kilometers because we had to get above most of the atmosphere to get rid of the atmospheric drag. Still a little bit of air up there. And we've been able to do that. So far, we've raised the apogee about 2 kilometers. And we spend about 2/3 of our time solar sailing and about 1/3 detumbling, as we say.
Huh.
And I could go into more detail. It's fascinating.
Well, I've got to ask what detumbling is. I saw it on your page there too, so I was wondering, what is detumble?
Sure. First, we have a big reaction wheel. Well, not that big. And boy, was it expensive. I can tell you these things cost a lot. Reaction wheel is just a flywheel inside the spacecraft. A lot of spacecraft have 3, so they can change X, Y, Z. We only needed it to change one axis. And that's because as we go around the Earth, and this is the big first that we did, other than doing it from a CubeSat, we have to change twice during each orbit, because when we're flying into the sun, we don't want to have those photons hitting the sail full on. We want to be edge on to the sun. But when we get around the orbit to where the sun is behind the sail, manner of speaking, then of course we want to be able to pick up those photons and accelerate. So that's what the reaction wheel does, because it has to do it fast. But, sorry?
You're tacking and jiving.
Exactly. We know how to tack, because you can tack into the wind just like people do offshore here. And we also, but the reaction wheel, as you use it, it just spins up to a certain speed and then it can't spin any faster. So we have to do other stuff to stop it and reorient the spacecraft. And we have the other way we orient the spacecraft. This is so cool. We didn't invent this. They're called torque rods. And they're little things, they're only about as long as your finger, but they're basically electromagnets. They use the Earth's magnetic field to slowly change the orientation of the spacecraft. And that's how we do the detumbling while we're getting the reaction wheel back down to 0 so that we can start up again. It's amazing how much technology it takes to make even a little tiny guy like this hang out in space for a while.
So you said it goes back 20 years to when you first started doing it. For this particular project, when did you start bending metal? When did you start building the craft?
Well, LightSail Development began about 10 years ago. A lot of the initial design, which is still there, was done by a local company called Stellar, and I think they started the actual bending metal quite a while ago, like 7, 8 years ago. But we had a lot of challenges trying to pull this together. Back then, CubeSats were still pretty new, and nobody had done anything like what we're doing with solar sailing. So there was a lot to work out. And there were times when we thought that we just weren't going to make it. We were going to have to give up. But we brought in some great new people and some really innovative thinking at some other places, like a company called Ecliptic, and a lot of other great folks who just wanted to see this happen because of this wonderful, romantic, and yet incredibly useful form of propulsion. And first we did LightSail 1 4 years ago, which was just a test. Because it only went up high enough, it was in too much atmosphere. We were able to deploy, but the air was too thick and it came down in a week. We knew that would happen. We had to wait until we could get a free ride from a Falcon Heavy to get up to this, not low Earth orbit, but mid-Earth orbit, to really be able to sail on the light of the sun.
Now, this is, of course, technologically fascinating because solar sailing is something that a lot of people have been talking about for a long time. But I want to focus for a second on the organization, because this isn't NASA that did it. It's not the Europeans. It's not even SpaceX. So tell us about the relationship between the Planetary Society, that you are where you work, and this project. How did it come about, and who paid for it?
Well, you paid for it, if you're a member of the Planetary Society. Do we have any members of our group here? Thanks.
Yay.
Thank you very much. You should, of course, be a friend of the observatory as well.
That's right. We have a totally symbiotic mission here.
It's a Venn diagram that's almost a circle.
Yeah.
You members and a lot of other donors. We had a few major donors, one who remains anonymous, who really made this happen. But you know, you're looking at something we are told that if it had been done by a major space agency, would have cost 20 times as much. So the whole project for us was about $7 million end to end. So think 140 if it had been done elsewhere. And that was entirely crowdsourced. There was no money from NASA, no corporate support or anything like that. Just a lot of people who were captured by the romance and the practical advantages for the future of what this kind of technology might be able to do within our solar system and maybe beyond our solar system.
Oh, say a word about that. I have one more question, then I'll throw it open to the audience. But why is this important for beyond the solar system?
Well, it's key that we call this light sailing. In fact, the guy who really ought to be here is our program manager, my colleague Bruce Betts, our chief scientist. He is in Aachen, Germany right now at the International Solar Sailing Symposium, which next time they hold it, they're going to change it to, I think, the International Light Sailing Symposium, because there is the thinking that rather than using the sun, which is great in a lot of the solar system, and it's a perfect application for doing things like monitoring solar weather and looking for asteroids with an infrared telescope, because you don't need to carry your own gas along with you. But you may have heard of, I'm sure you guys have, of the Breakthrough Starshot project. Breakthrough Starshot is the idea that we could take small light sails, even smaller than ours, maybe just a meter across, and launch them, and then hit them with humongous lasers for just a few minutes, and accelerate them to, the current thinking is to as much as 30% of the speed of light. Pretty cool. So think about it. You could get to some place like Alpha or Proxima Centauri in 12 years, maybe. 12, 13, 14, 15
You could do
years.
the Kessel run in 13
Good job. Yeah. Take that, Millennium Falcon. Got nothing on us. Now, we got a long ways to go, because at this point, they still can't figure out how to like vaporize the sail when they hit it with the lasers. So materials science is going to be a big part of this. You can't slow down, although Robert Forward did come up with a way to do that, kind of a double sail system. And, you know, electronics that might weigh just a few grams in the middle to transmit back to Earth. Anyway, they're thinking this may be practical, but we're talking way down the line.
Yeah, but once you get to Alpha Centauri, then you use its starlight. You need to have it optimized in red, but, you know, to slow things down. Okay, you laughed. Is that impossible?
Exciting. Well, they have talked about, yes, using other stars to help
because you got to bounce from star to star.
And even like swinging in really close to the star to do not a gravity assist, but sort of a gravity brake. Mm-hmm. So yeah, it's possible. But Forward's concept, it's too bad I don't have a slide of it. It's really pretty cool. It's like a central portion of the sail separates and reflects back on the ring that is left, and from the other side, and slows down the sail. He was
smart.
He was a smart guy. Anyway, so that's some of the potential.
So are there questions out there before I monopolize them completely? Yes.
What is the next step?
Well, we have no plans for LightSail 3. What we're going to do is, now this is technology that we hope will inspire and will be transferred to lots of other folks. We got a lot of praise from all over. Thomas Zurbuchen in NASA, the head of space science in NASA, just said what a great proof of concept, and talked about all the potential for this kind of technology. The next thing we're going to do that'll be similar is we're going to have a competition that won't happen until next year to pick technologies that we want to support. And so we're going to look to you folks and other people around the world, it'll be international, to try and come up with the next thing. But we want somebody else to build LightSail 3.
Yes.
I thought I saw some really small acceleration value, and do you have a reference for the nanonewtons of thrust, or what? What
Yes,
is that there?
somebody does the real numbers. The most I can tell you is there are two ways people often describe it, and one is that much, one piece of paper, or the weight of a fly. So it's somewhere between the two of those, I would guess. Yeah, it's not bad. Well, and we weren't the first to solar sail. Icaros, wonderful solar sail project from the Japanese Space Agency, very innovative, actually used LCD panels to orient the spacecraft that would turn on and off. Brilliant mission that went to Venus. They didn't have to orbit and change the orientation like we do, twice in orbit. And we actually have a higher coefficient of acceleration than they do because of the mass of our spacecraft and the photon catching capability of our sail, that proportion, ratio. Yeah, that's how I've heard it described anyway, by the boss. He's the science guy. He ought to know.
Yes.
What's happening with the satellite now? What's the lifespan?
Can you repeat the question?
Sure. The question was, what's happening with LightSail 2 right now? It basically automatically, autonomously reorients itself each orbit, but we have people who are still at this point around the clock monitoring, keeping track of what's going on. Up at Cal Poly, we have 4 ground stations around the world, so we can't really monitor it all the time. It has to be somewhat autonomous. We hope to continue actively raising the orbit for about a month. But because we only have control of one axis, we actually, as we raise the apogee, the high point, the perigee is lowered. And so eventually we're going to be caught by the atmosphere, and we're going to crash. We're going to be burned up. That's what will happen. And we have maybe a year, though, if we're lucky, that we'll be able to keep orbiting. But definitely for another month, we're going to be actively trying to raise the orbit.
Next question, yes.
How were you able to confirm that the momentum transfers by photons and not solar wind?
Well, there actually is. We do take the solar wind into account. And it's just a small fraction of what we get from the solar wind. And we know that just because we know a lot about solar radiation at Earth orbit and the flux of the solar wind. So we're able to factor both of those. But really, it's interesting. You wouldn't expect this, but the light of the sun dwarfs the effect of the solar wind.
Why can't you raise the perigee as well?
I'm no expert on this in celestial mechanics, and I've never read the Principia, but it does have to do with our inability to do fast reorientation of the spacecraft. The torque rods are cool, but they can't change it quickly, and we do only have really gross control on one axis. And I'm told that's why we can't do the perigee as well.
Okay, well, we have time for one more question.
I was just going to ask, you guys don't have any other means of propulsion other than the solar sails, but is it a possibility going forward to include solar sailing and other means of propulsion kind of coupled together?
That is such a great question, which I wouldn't have had a good answer for until this morning. There is, first of all, NASA, we knew had a project called NEA Scout, Near Earth Asteroid Scout, which will be a solar sail. And we've been working really closely with them on that solar sail project. But just this morning, I heard about a project that NASA's also working on, very early stages of development, that is a solar sail, but the sail, in addition to catching sunlight, is actually a thin film solar panel. And that thin film solar panel will run an electric engine, an ion engine, essentially. And so it will have both forms of propulsion. And so that's incredibly cool.
So we can explore the asteroid belt with a hybrid.
Yes,
in a hybrid.
yeah, it's a hybrid. Like the one I drive, it's a hybrid.
That's right.
Exactly
Just
right.
like the one you drive.
Yeah. yeah.
Right, my other car is a solar sail. Right?
Mine's kind of solar powered, but it doesn't carry it with it.
Yeah.
So, anyway.
Well, I'm going to ask you to stay up here because we have two more
Sure.
stories, and I want your comment on them. But let's thank Matt for his wonderful presentation.
Thank you.